This is the AP Stats Quideo number 2. Here's the basic question. Here are Professor Moore's times and minutes to swim the 2,000-yard race and his pulse rate after swimming these sessions. So as you can see, that's the data set. And what we're going to do with this data set is we're going to go into the calculator and we're going to hit Stat, Edit, and we're going to find them in list 1 and 2. So, once you do that, you're going to hit Stat Calc number 8. And you want to make sure that the X list is on list 1 and the Y list is on list 2. So, these are the numbers you're going to get. Our model equation, as it asks to find an A, is y equals a plus bx. And when we plug in our numbers, that is the equation we get. Y equals 446.245 and, well, minus 8.75x. So our A value, you can see, B value, R squared value, and R value. So question B asks that the next day's time is 34.30 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. How close is your prediction? So, our prediction, if you take the equation, is a pulse rate of 146. The prediction is off by about 6 beats per minute. For C, suppose you were told the pulse rate was 152. You want to predict the swimming time. Find the equation of the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? So, what we're going to do is we're going to actually go back into the calculator. We're going to hit Stat. We're going to go to Calc. We're going to go to number 8. And we're actually going to switch list 2 and list 1. And then these are the values it will give us. As you can see on the paper. So, our model equation is y equals a plus bx. And we got y equals 43.46772 minus 0.06046983x. So, A equals 43.46, B equals negative 0.060, R squared is 0.530, and R is 0.728. So, when we plug in this equation and put in a pulse rate of 152, we get a predicted time of 34.255 minutes. For D, it is asking to clearly explain to someone who knows no statistics why there needs to be 2 different regression lines for parts A and C. So, there needs to be 2 different regression parts because the original solves for the y-axis values, whereas the second equation solves for the x-axis values. To find these, just switch L1 and L2 values in the calculator. So, next is the advanced question. To the right are the data collected on the prices and capacity of hard drives. Below is the regression of the price versus capacity. So, here we go. That's what we got. And here we have the prices in response to the capacity of terabytes. So, question A asks, without the use of a calculator, write the regression equation to find the variables used in your equation. You may use a calculator to check your equation for accuracy. So, our model equation is y equals a plus bx, and then y equals 18.617 plus 103.929x is our equation. So y is the predicted price. 18.617 is the price when terabytes are at 0, so it's the intercept. And the 103.929 is the dollar amount / total price that goes up every 1 terabyte. So, for part B, explain the meaning of the slope and y-intercept in context. So, slope is the predicted price for the capacity of terabytes needed, and the y-intercept is the starting predicted price for 0 terabytes. So for C, we need to predict the price of a 3.0 terabyte drive. So what we're going to do is we'll take the equation y equals 18 plus 617 plus 103.929 times 3. So we're substituting that for x, and that's going to give us $330 and about 40 cents. So for D, Mr. Shaheen found a 3 terabyte hard drive for $300. According to your regression equation, determine why this is a good or bad buy. So this is definitely a good buy for Mr. Shaheen. A 300 terabyte hard drive for $300 is an awesome deal, and he's saving about $30. He's saving about $30 from a predicted terabyte price. Buying the $3 terabyte hard drive is actually a steal, and the opportunity should definitely be jumped upon. Next, we have the AP question. Windmills generate electricity by transferring energy from wind to a turbine. The study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. 4 of the windmill measurements were taken on 25 randomly selected days. And the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. So that's right here. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 miles per hour to 40 miles per hour. So these are our values from the computer output. We have the coefficient, the SE coefficient, T, and the P. And then we have the S value, the R square value, and the R square adjacent. Question A says to use the computer output above to determine the equation of the least squares regression line. Identify all variables used in the equation. So what we're going to do is we would flip around the L1 and L2 values, and this is what we're going to get. So y equals 0.137 plus 0.240. The y is the predicted electricity output, and the 0.240x is the wind velocity. So that's what we get there. And for B, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour rather than a wind velocity of 15 miles per hour? Show how you arrived at your answer. So what we have here is we have our equation, and what we're going to do is we're going to plug in 25 for x. So we'll take 0.137 and we're going to add that to 0.240 times 25. So we multiply those and then we add it to 0.137, and these two equal 6 exactly, and then we have our y value of 6.137. So that's how many amperes that it will create. And then on the 15 mile an hour day, we'll do the exact same thing. So 15 times 0.240 plus 1.137 equals 3.787. So after that, we'll take 6.137 minus 3.87, which equals 2.35. And that's going to be 2.35 more amperes on that specific day of 25 mile an hour winds compared to 15 mile an hour winds. Next for C, What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? So, the proportion of variation that is explained by its linear relationship with wind velocity is the r square valued. In the output, it is stated that the r square is 0.873, as you can see right there. That is our answer.